Lesson B has several parts. The first part is on perimeter, and all of this lesson will be a geometry review. Now, if you recall, perimeter, when you're talking about perimeter, that means the distance around an object. For example, if you had, let's say this was a fence to your yard. Maybe your yard is a rectangular shape, and that line or set of line segments that I just drew represent the perimeter around your yard. And that would also equal how much fencing you had around your yard, if your yard had fence around the entire thing. So perimeter, that has lots of applications. For example, figuring out how much fence you would need to put around your yard. Perimeter means the distance around. And for us in math class, we consider that a flat geometric shape. The distance around a flat geometric shape. Now the perimeter of a circle, that has a special name. It's called the circumference. And if this circle here had a radius of r, the circumference, c, we'll call it c for circumference, is equal to 2 times pi times that radius r. Or we could also say that it's equal to pi times the diameter. Since the diameter is equal to 2 radii, then it's also equal to 2 pi times the radius. Remember, a diameter is the distance from one end of the circle to the other, right through the middle. So it's 2 radii. This is not a diameter, that red line segment that I just drew. That would be called a chord. A chord doesn't pass through the center. If it does pass through the center, then it's called a diameter. Now we could think of that relationship c, the circumference, equals pi times the diameter. Pi, that's just a symbol, a Greek symbol for the value 3.14, and it just so happens that, we can just use some algebra here, divide both sides by the diameter. Pi is equal to that ratio of the circumference to the diameter. For any circle, it doesn't matter what the circle is, the ratio of that circle's circumference to its diameter is equal to pi, and we usually consider pi to be equal to 3.14. So I'll put that down here. Pi is equal to 3.14, and that's just rounded to 2 decimal places. Pi really has an infinite number of decimal places. It's considered an irrational number. For our purposes, we'll just consider pi to equal 3.14. So to figure out the perimeter of a circle, you need that formula. The circumference is equal to pi times diameter, or 2 times pi times the radius. The perimeter of a geometric shape like a rectangle, you just add up the lengths of all the different sides. Next, let's talk about area. Now, perimeter always has units of length, like meters or feet or inches or miles. Area has units of length times length, or meters squared, inches squared, miles squared, etc. The reason it has units of length times length is because we're always multiplying 2 lengths together when we figure out an area. Now, for rectangular shapes and squares that have right angles for all of their corners, the area is equal to the length times the width, and I'll just say L for length times W for width. And if it's a square, it's just one side. All the sides are the same in the square, so it's side times side, or side squared. I'll use a little subscript here. Area subscript R for rectangle equals length times width. Area subscript S for a square is equal to side squared, or side times side. Now a triangle, the way you figure out a triangle is it has a base that we consider to be a length B, and then it has a height perpendicular to that base. I'll put a little right angle box there so we know that's perpendicular. So it has a base and a height perpendicular to the base. The way you figure out the area for a triangle, if you remember, say A subscript T for triangle is equal to the length of the base times the height divided by 2. Now just think about it. Think if we had this triangle right here. It had a base B and a height H. So that's a right triangle because we put that little right angle on the end there. The height is perpendicular to the base. We would calculate its area, base times height, divided by 2. Now, let's just draw another triangle right above it and adjacent to it. Now that whole thing looks like a rectangle, right? With a length of b and a height of h. So you can think of a triangle as half of a rectangle. That's why we do length times height divided by 2. A triangle can be considered half of a rectangle. Notice also that we're multiplying two lengths together. That's always what we do when we calculate area. Lastly, let's think about a circle. Now, just like in perimeter, we have a special formula that we use to figure out the circumference or perimeter of a circle, 2 times pi times radius. There's a special formula for the area of a circle as well. We'll say a subscript c. That's equal to pi times the radius again, or pi times the radius squared. And so in all of our area formulas, we're multiplying two lengths together, and so that's why our units for those are always in units of length squared. So some formulas to memorize here. Those include the circumference of a circle, that's equal to 2 times pi times the radius. Area of a rectangle equals length times width. Area of a square is side squared. Area of a triangle is base times height divided by 2. And then area of a circle is pi times the radius squared. Now volume, that has units of length cubed. Perimeter has units of length. Area has units of length squared. Volume has units of length cubed. So you should understand therefore that you multiply 3 lengths together to get volume in length cubed. So let's say you had a cube. A cube is a shape that all of the sides are the same length. Let's just say they all had a unit of 1 as a side, or 1, let's just say units of inches here, 1 inch on each side. So that cube there has a volume of 1 cubic inch. Now let's think if we had a rectangular solid shape that had a length of 6 and a length of 2, and this height was also 2. We could break that up into 24 cubes basically, and we could just draw some lines here to split this up into 24 1 cubic inch cubes. And so now it looks like 24 1 cubic inch cubes. So when you think about volume, you can think about how many cubes that you can fit into a particular geometric solid. Now, geometric solids like the one on the left there, and then the 3 that I have there, there's like a right cylinder, a right triangular prism, and then just a right cylinder, it could be called. The one on the left, we call it a right circular cylinder. The one on the right, we just call it a right cylinder because it's just a curved surface. It has a curved surface for its bases. All of those, their sides are perpendicular to the bases. So that means we could draw a little right angle off of each one of those vertical sides to the base. Those are all perpendicular. So that's why we call them right solids. Now, it just so happens that the area of the base of any of those solids times the height perpendicular to the base, that is equal to the volume for that solid. Whether it's a rectangular solid, a right circular cylinder, a right triangular prism, or just a right cylinder. Now it's very interesting that the same formula holds true for a solid like the one I have, that's right circular, or not right, but a circular cylinder that I have drawn below. Even though the vertical sides are not vertical anymore, they're not perpendicular anymore, they're at angles to the bases, as long as the bases are parallel to each other, then you can still use the same formula, area of the base times the height perpendicular to the base. So on a problem like this, they would give you this height right here, the height perpendicular to the bases, not the length of the side between the bases. Now the height perpendicular to the base is no longer the same thing as the length of the side. So that's the thing you have to remember about volume. And this is something that you haven't learned yet. This is something different that was not in the Algebra 1 textbook for Saxon. They didn't talk about cylinders that were not right cylinders. But you use the same formula. It's just that's a property of solids. And it works for more than just cylinders. It works for prisms as well. Remember, they're called right prisms if their sides of their bases are line segments. So just to make that clear, on those three right solids, the one on the left is a cylinder, the one in the middle is a prism because the sides of its bases are line segments. The one on the right is a cylinder because the sides are not line segments, they're curves. Now, something you did learn in Algebra 1 was the volume of a cone and the volume of a pyramid. I'll just say V sub C or V sub P for pyramid. The volume of a cone or a pyramid, that equals 1/3 the volume, or 1/3 the area of the base times the height. And it's still the height perpendicular to the base. So you could have a cone, say like this, that went off like that maybe. This height perpendicular to the base, not the length of the side like that. You need to know the height perpendicular to the base. So that height times the area of the base, then times 1/3, that would equal the volume of that cone or pyramid. Volumes of cones and pyramids, those equal 1/3 the volume basically of a cylinder or a prism inside which that cone or pyramid would fit. Cones have a curve for their base just like cylinders do. Pyramids have a line segments for their base just like prisms do. And lastly, let's talk about a sphere. The volume of a sphere is equal to 4/3 times pi times the radius cubed. Now the volume of a sphere is also equal to 2/3 of the volume of a right circular cylinder into which the sphere fits. So in the Algebra 1 3rd edition they gave us that formula there, 4/3 pi r cubed. I think it's better to use that formula to talk about the volume of a sphere, because when you're talking about circular shapes you have a formula for the area of a circle, you have a special formula for the perimeter of the circle called the circumference. So it just goes together that you would have a special formula for the volume of a circular shape, which is a sphere. If it's easier for you to remember the volume of a sphere by 2/3 the volume of a right cylinder into which that sphere fits, then go ahead and use that. But I just think it's better to use a formula, 4/3 pi r cubed. Now let's talk about surface area. Surface area, if you can remember what I have up there in the red, it's the sum of the area of the faces. And that's for a solid object. And so like for that right rectangular solid there, you might look at that and say, oh well, it has 3 faces on it, so I'll just figure out the area of each of those and add it up. That would be my surface area. But you have to add the hidden lines in, and just be careful on those. There's actually 6 faces there, and you need to calculate the area of all 6 faces. So you add all of those up together, and that would be the total surface area for that right rectangular solid. Now for a right circular cylinder like this, you could figure out the total surface area first by calculating the area of the 2 bases, and both of those would have the same area. So you figure out one, you have the other one figured out, and then you have to figure out the lateral surface area. Lateral means sides, and that's this surface here. So like if you think about a Coke can is a cylinder. Where you hold the Coke can when you drink it, that's the lateral surface. You're holding onto the lateral surface. Now a good way to understand how to calculate the lateral surface area is to think of a roll of paper towel. Let's say you had this roll of paper towel and you unrolled one piece of paper from that paper towel. You know how there's perforated sections between the pieces, and say that piece wrapped around one time exactly around that paper towel roll. And so once you unroll that sheet of paper towel off of that cylindrical shaped roll, you see that that sheet has a rectangular shape to it. And like we said, if that sheet wrapped around exactly one time around that paper towel roll, that would be equal to the lateral surface area for that particular paper towel roll. So for a right geometric solid, whether it's a cylinder or any kind of geometric solid, it just has to be a right geometric solid. The lateral surface area, we'll call it LSA, that's equal to the perimeter times the height. For a right circular cylinder, that perimeter would equal the circumference. And so that would be circumference times height. For a right triangular prism, like I have drawn there, that would be the perimeter of the triangular base times the height perpendicular to that base. That would be the lateral surface area. So you could calculate the total surface area of that right triangular prism either by calculating the area of each face and adding that up individually, or you could figure out the area of the two bases, which are the same, and then the lateral surface area, you could just do perimeter of a base times the height. You could do it either way. Then a shape like this, where you've got a curved surface there, you would want to use perimeter times height perpendicular to the base for that. You couldn't figure out the lateral surface area just by using a simple geometric formula. You'd have to do the total perimeter of the base times the height. So some right solids you can use you can figure out the surface area by adding up all of the faces together. Some of them you can figure it out by adding up the sum of the faces, or by figuring out the top and bottom face, and then the lateral sides just do perimeter times height perpendicular to the base to figure out the lateral sides. Now a sphere, that has a special formula for its surface area. Just like all the circular shapes do, they have special formulas for their circumference or perimeter, area, and volume. A sphere, its surface area, we'll just say SA subscript S is equal to 4 times pi times the radius squared. So you can't use like perimeter times height or anything like that for a sphere. You have to use 4 times pi times r squared. That's the formula that you have to use. Now a cone that has a cylinder for a base, a circular cone in particular on this, that's what we're talking about. So its base is a circle. A right circular cone, to be even more specific, that means its height is perpendicular to the base, also known as its axis. You could figure out the area of the base just by pi r squared since it's a circle. The lateral surface area, though, we'll say LSA for a cone, that's equal to pi times the radius for the base, and then times S, which is the length of the side. So that's what S is the length of one side. And if we call that height between the top of the cone and the base, we'll call that H, and then the distance of the radius will give that a length of R. We could use the Pythagorean theorem to figure out the length of that side, because that's the hypotenuse of a little triangle, right? S squared is equal to H squared plus R squared, and so S is equal to the square root of H squared plus R squared. So for a right circular cone, the lateral surface area has a special formula too. Pi times the radius times the length of a side. If you were given the height of that cone and its radius, you could figure out the length of a side using the Pythagorean theorem. Memorize those formulas: surface area of a sphere and lateral surface area of a cone. Let's go ahead and do a practice problem. I have a right solid there, right geometric solid, and the base is kind of a strange shape, so I've redrawn that at the bottom, and all of our units here are going to be meters. What I want you to do is find the perimeter of the base, the area of the base, the volume of the solid, and the total surface area for the solid. So there's 4 things that I want you to calculate here. And so let's just start out with the perimeter, and we'll just say P subscript B, and let's just look at our area of the base shape that I have drawn there. And that left side, we don't have a length for that left vertical segment, but we have a length for the radius of 2 meters, and so the diameter then would be 4 meters, and that would have to be the length of that left side. So that left side is 4. And so then that 7, when they show like a segment of 7 meters and you've got a circular shape on the end, they mean from here to here. That's the 7 meters that they're talking about. Okay, so we could assume above that is also 7 meters. So we'll have 2 7-meter lengths, which is equal to 14, plus that 4. And then we have half of a circle basically over there on the right. And just think about when you do perimeter, think of traveling around the object. So look at this line that I'm drawing. You'd go 7 plus 4 plus 7 and then plus half a circle. You just add up those different sections to figure out the perimeter. And so for half of a circle, we know what the circumference of a whole circle is. It's 2 times pi and times the radius. In this case that would be a 2. So 2 times pi times 2, but it's just half of a circle. So we'll divide by 2, and then we could cancel there. And so now we have 14 plus 4 is 18, plus pi times 2, that would be 3.14 times 2, or 6.28. And so that just equals 24.28. And then our units are meters, and units on these type of problems are just as important as the numerical answer. I think so anyway. Because if you were trying to tell somebody about a certain geometric shape and you just said, oh, well, it has a perimeter of 24.28, and how would they know if you're talking about meters or inches or yards or whatever? For example, if you were buying fence for your yard, you would calculate the perimeter of your yard, and that would tell you how much fencing to get. And say you did that in yards and you had to get 30 yards of fencing, but you went to the lumber yard and you said, they say, how much is your perimeter? And you say 30, and they think it's meters and you said it was yards. Then you get some confusion there. You wouldn't get the right amount of fencing that you needed. The units are just as important as the numerical part. And so that means if you got the units right on that problem, but you got the numerical part wrong, I think the problem would still be worth half credit. If you got the number part right and the units wrong, it would be worth half credit. So that's perimeter for the base. Now let's figure out the area of the base. And so we'll say A subscript B. This should have units of length squared, right? Perimeter has units of length, area of length squared, because we multiply lengths together. Now the best thing to do for area of the base on a problem like that is to break it up into geometric shapes that you're familiar with. And I see a rectangle and then half of a circle. And so let's figure out the area of each of those individually, and then we'll just add them together to figure out the area of the base. So we have a side of 4 and 7 on the rectangle, so that would be 28. 4 times 7 is 28. And then half of a circle. Well, we need to think of our formula for the area of a circle. Pi times the radius, which is 2, squared, divided by 2 because it's half of a circle. That's why we divide by 2. We're just looking at half of a circle. And so that would simplify to 28. And then since we have 2 squared over 2, that's just the same thing as times 2. And so pi times 2 is equal to 6.28. And so then we end up with 34.28 meters squared, because we multiplied length times length. Meters times meters is meters squared. So that's the area for the base, 34.28 meters squared. Next, I wanted y'all to figure out the volume. So figure out the volume for this right solid. And that's equal to the area of the base times the height perpendicular to the base. And so that would just be 34.28, which we just calculated in the previous problem, times 9. Now, the purpose of a geometry problem like this is not to do the multiplication. See how good you are at doing multiplication out on paper. The purpose is applying the appropriate formulas to the problem to get the correct answer. And so I think it's fine to use a calculator on these. And so you can just say 34.28 times 9, and that equals 308.52. Now we just multiply the area of the base, which is length squared, times the height, which is another length, so that's length cubed, or meters cubed. 308.52 meters cubed is the volume for that right solid. Let's do one more calculation. I wanted you to figure out the surface area for this shape. So we'll say surface area. That's going to be equal to the area of the base or bases plus the lateral surface area. So let's just think about this. Let's add the hidden lines in here. We've added our hidden lines on our geometric shape. So that helps us recognize, oh yeah, we've got two bases. So we know what the area of the base is. Multiply that by 2. 2 times 34.28. Add to that the lateral surface area. So the lateral surface area is equal to the perimeter times the height. We know what the perimeter is. That's 24.28 meters times the height. That would be equal to 9 meters. And so if we add those two things together, again, that's fine to do that on a calculator. That would equal 287.08 meters squared. That is the total surface area for that shape. Surface area would be important on a shape. Just think about if you were painting a surface and you needed to know how much paint to get. Well, usually the paint cans tell you that this paint will cover this much surface area. So if you could calculate the surface area for the object you wanted to paint, that would be an important thing. And you could easier estimate how much paint you needed. Surface area, just like regular area, has units of length times length, or length squared. Now remember, when you're doing the problems or doing the lessons, you need to do the problems with me. Don't be just sitting and watching me do all these problems. You're supposed to be working them along with me and trying to figure them out. And these review lessons, they're pretty long. All of your lessons will not be as long as this, so just keep that in mind too. Most of your lessons will be a lot shorter than this. And we have one more section to go on sectors of circles, so let's go ahead and do that next. Now when we draw a circle, we usually have a center that we consider, and then we just draw the circle around that center. It's hard to draw a circle perfectly. I had to move my center point there a little bit so it looked a little bit better. Now let's just consider one part along the circumference or perimeter of that circle. Let's just consider a section of it from here to here. Okay, and I'll draw a line segment from the center to the edge to designate that section. Now those two segments that I've drawn, we could consider each one of those a radius of the circle. So the pair of those, we could consider those radii. The angle that formed in between them is about a 45-degree angle. And what we would say is that little section of circumference, we would call that the arc. The area that is enclosed in between the two radii, that's called the sector. And it's like, if you looked at that, if that was like a piece of pizza, and that section in between the two radii, you consider that a piece of pizza, you could take that out. That would be considered the sector. The crust of the pizza, that would be like along the edge of the circle, that's the arc. So an arc, that's equal to the fraction of the circumference. And then a sector, that's equal to a fraction of the area. Well, how do you figure out what fraction you're dealing with? Think about it. In a circle, let's just start as our initial spot on that bottom radii and go around. we would have 360 degrees that we traveled. If we go around the entire circle, that's 360 degrees. So for every arc, that's a fraction of 360 of the circumference, of the total circumference. The sector, that's a fraction of 360 of the total area of the circle. Let's just go ahead and do a practice problem. Look at this one. Given that circle, and then I have that angle x in there, it's equal to 30 degrees. Find the length of a 30-degree arc and the area of a 30-degree sector. So the radius is 3 inches for that circle. The length of a 30-degree arc, that would be 33/60ths of the entire circumference of the circle. So just write down the circumference of the circle. That would be 2 times pi times the radius of 3. And then multiply that by 30 over 360. Now 30 over 360, that would simplify to 1 over 12. And then we have 2 times pi times 3. Remember, order doesn't matter in multiplication, so we could just say 2 times 3 times pi, or 6 pi divided by 12, which is just pi divided by 2. That's what that would simplify to. And so we consider pi to equal 3.14. We can just do that on our calculator. 3.14 divided by 2 is 1.57. Or if you can do that in your head faster, then do it in your head. So the arc, we'll just say arc equals 1.57. It's a perimeter, or part of a perimeter, so the units would be inches. Make sure and put your units. The arc is equal to 1.57 inches. Now the area of that sector, that's a fraction of the entire area based on, it's a 30-degree sector, so it would be 33/60ths of the total area. So figure out your total area, which would be pi times the radius squared, which is 3 squared, and then times 30 over 360 again, or let's just go ahead and say times 1/12. Okay, so now we can say that that's equal to 9 times pi divided by 12. And we could simplify that if we wanted to some more, or let's just go ahead and calculate it out. 9 times 3.14 divided by 12 is equal to 2.355, or let's just round it to 2 decimal places, 2.36 inches squared. And so that would be the area of that section. 30 degrees out of an entire circle is 1/12 of that entire circle. So 2.36 inches squared is 1/12 of the area of that entire circle. So try to remember that. This is something new. You didn't have this in Algebra 1 if you did Saxon for Algebra 1. An arc, that's equal to the fraction of the circumference of a circle. Sector, that's equal to the fraction of the area of a circle. And you figure out the fraction part by multiplying, or not by multiplying, but by figuring out the fraction over 360 of the angle that you're using for the measure of the arc in the sector. Okay, well that's all for Lesson B.